In this video, on the first lesson in statistics, we're going to look at something called the interquartile range. In the past, you might have come across this word of range, and you probably would have calculated in the past. The range tells us how far apart values are in a data set. We would take the highest value and the lowest value, and we'll work out the difference between them. If the range was large, it would imply that the values in the data set are quite far apart. If the range was small, it would imply that the values in the data set are quite close together. And if they're quite close together, you could assume that the values in the data or in the data are much closer together. I'm going to try and show you an example here and look at maybe why the range doesn't cut it in all examples. I want to imagine that we've got two rooms, room 1 and room 2, and the ages of people in the rooms were recorded. Okay, so in room 1, we had a 20-year-old, a 20-year-old, a 23, 27, 29, 32, 35 and a 44-year-old. So if you wanted, we could work out the range here. The range in room 1 would be 44 minus 20. So the range in room 1 is 24 years. Okay, there's a spread of ages and it's from 20 to 44. In room 2, we could work out the range once again in room 2, and we would do 50 subtract 18, which is 32 years. So in room 2, they're 32 years apart. So we would then say, okay, in room 1 the range is smaller, therefore room 1 the ages are more consistent, therefore the ages are closer together. That's what we would assume. But see, upon some closer investigation, see if we have a look at room 2 and see if we ignore that last 50. The ages in room 2 are really consistent, they're really close together, much closer together than in fact what we've got in room 1. Yeah, these are much more spread out. Okay, so although the range is bigger, which implies less consistency, it actually looks like they're more consistent. And this is where we introduce the idea of the semi-interquartile range. It's another way to work out a range, but we don't look at the endpoints because they could skew the data one way or another. To start off with, we're going to introduce the idea of quartiles. Okay, and a quartile is something, hopefully you'll appreciate, is going to split something into 4 parts. Quartile 4. But I just want to kind of recap something before we get going. Here I've got a list of numbers I'm going to ask you to copy down. It's an ordered list of numbers. It goes from smallest to highest. What we're going to do here is we are going to find the median. If you recall, the median is the middle value. So what we could do here is we could work into the middle value. So we would go, I'd probably assume just putting your fingers on them. 2 and 25, 6 and 13, 6 and 11, 7 and 10, 7 and 10, 7 and 8, 7 and 8, and then we're left with this value here in the middle, which is our median. And the median splits our data set into 2 equal parts. Because to the left of the median there is 1, 2, 3, 4, 5, 6, 7 values. And to the right of the median there is 1, 2, 3, 4, 5, 6, 7 values. So this here has split the data into 2 halves, 2 equal halves. What we're going to do is we're going to introduce the idea of quartiles. So we're going to split them into 4 quarters, into 4 equal parts. So what I've got here is I've got the exact same list of data. Can I actually copy this down again? And just as before, we're going to circle the median. Like so. What we're going to do though, to split it into 4 parts, is see to the left of this circle here, see to the left of this 8, we're going to work out the median of this left hand side here. We're going to work out the median of this part. So if we were to do that, I'll get a different colour. So 2 would match with 7, 6 would match with 7, 6 would match with 7, and I'd be left with this 7 here. Similarly on this side, 8 would match with 25, 8 and 13, 10 and 11, and I'd be left with 10 here. I just wanted to have a look at what we've got left over. I've got 3 values here, 3 values here, 3 values here, and 3 values here. We have split the data into 4 parts. We've got special names for these. This is the median. this is the lower quartile, and this is the upper quartile. But you see altogether we've got 3 quartiles here. We've got quartile 1, quartile 2 and quartile 3. So that's how we name them. This is referred to as Q1, Q2 and Q3. And the idea of the semi-interquartile range is built up upon those quartiles. That's Q1. Okay, so here we've got just a couple of examples to work through to try and find the quartiles, make sure we can do it properly. We'll get a part A and a part B. It says find the quartiles of the following data sets, so make sure you get these copied down. Notice here the data set is in order already. So we're going to work and first find the median. So put your hands or your fingers in the two end numbers, 2 and 20, then work in. 3 and 19, work in. 3 and 17, 4 and 17, 5 and 15, 5 and 12, 9 and 11. But do you notice in this example, I don't have one singular number to work to. My median is going to lie in between these two values here. So we need to ask ourselves, what's in the middle of 10 and 10? Well, it's 10. So Q2 is 10. What we're now going to do is we're going to work out the median of all the numbers to the left of where Q2 is. Okay, so we're going to go 2 and 10, 3 and 9, 3 and 5, and once again it's going to be in between two numbers. In this case it's going to be in between 4 and 5. So Q1 is 4.5. And then we're going to do the same idea for all the numbers to the right of the median. Gold. So 10 and 20, 11 and 19, 12 and 17. So our median is going to be in the middle of 15 and 17. What's in the middle of 15 and 17? Well, it is 16. Okay, so that's how we identify our quartiles. Once again, just to reiterate, I'll go blue. Here we've got 4 values. Here we've got 4 values. Here we've got 4 values. And here we have 1, 2, 3, 4 values. Okay, split it into 4 parts. Right, another example. Once again, this is ordered already, which is nice. So we want to find the median to start off with. So 2 and 11, 4 and 9, 5 and 8, 6 and 8, 6. So this is our median. We'll then do it for the lower quartile. So we've got 2 and 6, 4 and 5. So it's going to be in between 4 and 5. So Q1 is 4.5. And then above the median, 8 and 11, 8 and 9. It's going to be in the middle of 8 and 9. So Q3 is 8.5. Okay, so now we've seen the idea of how to work out quartiles. We can now use this to try and work out the semi-interquartile range. Okay, so I'm going to ask you to copy this down and highlight this or bubble it and make it important. This is not given to you in your formula list. To calculate the semi-interquartile range, we use the formula SIQR, that stands for semi-interquartile range, Q3 minus Q1 over 2. Essentially, we work out the difference between the upper quartile and the lower quartile, and then we half. And that gives us a better idea of how spread out the data is. It doesn't take into account the endpoints, because we could have endpoints that really raise the range or make the range or it would certainly raise the range at least. But here we're just looking at like this middle section. If I zoom back here, essentially what we do is we just work out the range of this section here. Okay, and then we have. Okay, so we've got one example. Calculate the SIQR for the following data set. And we've got this data set here. The first thing you must do is you must ensure that your data set is ordered from smallest to biggest. Okay, so you need to make sure you get this rewritten in order. So we're going to have 1, 3, 4, 5. 1, 3, 4, 5. Oops. 1, 3, 4, 5. Don't have any 6s. I've got 2 7s. 7, 7, 8, 10, 10, 12, 14. Okay, and you should be able to check that your values, you've got the same number of values. Okay, so to calculate the SIQR, we need to work out the quartiles to start off with. We need to find our middle value. So 1 and 14, 3 and 12, 4 and 10, 5 and 10, 7 and 8, 7. So this is Q2. Okay, we need to work out our lower quartile. 1 and 7, 3 and 5, 4 is our lower quartile, Q1. 8 and 14, 10 and 12, 10 is our upper quartile, Q3. So, once we've done that, we can work out our semi-interquartile range. So to work out the semi-interquartile range, we'll do Q3 minus Q1 over 2. That's going to be 10 minus 4 over 2, which is 6 over 2, which is 3. The semi-interquartile range for this data set is 3. It's important you can interpret what a semi-interquartile range is. Just do this here. If the semi-interquartile range is smaller, that would mean that the values are closer together, which would imply more consistency. Or another way you want to say the numbers are less spread out. And if the semi-interquartile range was larger, we would say that they were less consistent. Less consistent. I'll just put less consistent. Because they are more spread out. Okay, sometimes you might be asked to interpret, if you're given two data sets and their semi-interquartile ranges, you might be asked to compare them. So you would have to look at, say, which one is smaller, and then say something along the lines of consistency or spread. Okay, so that's how we're calculating the semi-interquartile range. Once again, this formula here you are not given, you need to be able to replicate in an exam situation. Thank you very much.